Shake Table Lab by Ellen Carter and B. Perret. Our first step was to create a design of what we wanted our structure to look like. Using the app Sketch, we entered the dimensions and the measurements of the tower, then made the sketch. The requirements for the tower were that the tower had to be at least 36 centimeters tall. The first story had to be at least 18 centimeters tall. We aimed for our tower to meet the requirements by sketching it as 36 centimeters. The first thing we did when we started building the tower was create our base. We then doubled straws and created long supports to hold up our floors. After we made our long supports, we connected them to each other so that while we were building, the straws would stay in place. We connected the straws by folding the top of one, then inserting it into another straw. To ensure more support, we taped the top corners. Next, we created cross supports. We believed that the crosses would provide the best support when the tower was shaking. We added cross supports to both the floors and all four sides. After our sides were complete, we made floors on the top and on the bottom for the sandbags to sit on. To add even more strength to our tower, we boosted the side support with another straw on each side. Then, we put the supports in the middle of the tower to increase the stability in the center. Finally, we covered the floors in construction paper. In total, our tower was 52 centimeters tall and 19 centimeters wide. The free choice story was 15 centimeters tall and 15 centimeters wide. Without the free choice story, our tower is 37 centimeters tall and 19 centimeters wide. The static testing was an intro of what was to come throughout the shaking. If any straws bent or shook, it was a sign that the tower wouldn't last long. With the extra straws we had, we added supports in the middle of our tower, both on the first and second floor. On the first floor, we created supports coming out from all the corners, and on the second floor, we created supports standing straight up. The strongest areas on our tower were the corners and the sides. We had supports that intersected in the middle and a whole lot of tape to secure the sides. Unfortunately, the center of our tower was not as strong as we thought it was. We used the extra straws to increase the strength, but it still wasn't enough. The structure failed towards the center due to a lack of support on the first floor. Tape was an essential component for our structure. We used an obscene amount to add maximum support. Not only did we use it to connect straws, we used this tape to add strength at the corners and on the sides. All of our extra supplies were used to increase strength, instead of using them for decoration. We created a very simple design for the top story, purposely so we could have extra straws for the bottom. We added center supports and side supports with the extra straws. In order to see how strong our tower was, we put it on the shake table and added weight to it. We started with 4 sandbags, and after each shaking, we increased the weight by 2 sandbags.
Are you supposed to be videoing?
Yeah.
Oh, it's shaking.
No, the top is shaking.
The tape is...
Our structure finally failed after it tried to hold 20 sandbags.
Oh my god! No way!
While the tower was on the shake table, we wanted to be able to record the movement of it. To do this, we connected a USB sensor to the shake table. The sensor took the data of the shaking and created a graph. The XYZ graph shows the movement of the tower in 3 different sections: the side-to-side motion, the back and forth motion, and the up and down motion. The Z-axis is the up and down motion. The Y-axis is the back and forth motion. The X-axis is the side-to-side motion. The greater the movement per section, the more space between each zigzag. Because the tower moved side to side the most, the lines are more spread out. Because the tower didn't move up and down a lot, the lines are very close together.
My name is Beatrice Prey, and today I'll be talking to you about our shake table structure. Our structure held 18 sandbags but collapsed at 20. Our building failed in the middle because we didn't have enough supports. To make our tower stronger, we would have added more supports in the center near our floor. I learned that it's very hard to make a stable and safe structure with a limited amount of resources. What I enjoyed about the lab and building was getting to test out our strategies and seeing if they worked.
My name is Ellen Carter, and today I'll be talking to you about our shake table structure. Our building held 18 sandbags. Our building failed towards the middle of our tower. I think it collapsed because our floor wasn't as strong as it appeared to be. I think we could have added more straws to our second floor to add more support for the floor. I learned that it is a very complicated process to earthquake-proof a structure, and if something went wrong, people's lives would be in danger. Therefore, you must add as much support as you can. I enjoyed building the third story of our structure because we were able to be creative and do whatever we wanted.